In this video on probability, I'll be talking about disjunctions and complements. And so a disjunction, and you see that the language here is very similar to what we had in logic, where the conjunction was and. The disjunction is or, and this is an inclusive or. And so what we have with a disjunction is the probability of A plus the probability of E, and then minus the probability of the conjunction of A and B, so the probability of A and B. And so we can see, well, first thing first is a lot of people, I think, are sort of confused by this subtraction. Why do we want to do this subtraction of this conjunction here? And so the reason for that is because we don't want to count the conjunction twice. So we see here that the inclusive or, so we have boy here. So this is using the boy and girl. So we have boy or girl, and then we have boy and girl here. So the inclusive or contains this boy and girl here, but we don't want to count that twice because we're counting, we're counting boys and then we are counting girls. And so we see that this is actually getting counted twice. So I made this figure down here. So when we are doing this conjunction, we're adding up this gray area. So we see the gray area for boy contains the boy and girl, and then we add the area for girl, which also contains the boy and girl. And so we can have this be sort of equal to, all of just the boy plus all of just girl. And then we're adding this here twice. So we see that if we go from here down to here, we're adding it there. And then here down to here, we are adding it there. And so I'm kind of belaboring this point because my job in the real world is actually a tutor in things like chemistry and math. And one of the things I tutor is statistics. And in the disjunction, I think this is probably one of the things that trips people up the most is why are we subtracting this conjunction here? And then, of course, if we were doing an exclusive or, we would actually put a 2 here in front of that because we would want to subtract out both of the conjunctions there, so both places where it is boy and girl. But since we are going to be pretty much exclusively talking about inclusive disjunctions, then we will only subtract it out once. And so if you don't do the subtraction, it would be like saying that a 50% chance of rain on Saturday and a 50% chance of rain on Sunday means there is a 100% chance of rain over the weekend. And we can see how that would work. So if we have a 50% chance of rain on Saturday and a 50% chance of rain on Sunday, there is a chance that it's not going to rain on both of them because, there's a 50% chance of not rain on Saturday and also a 50% chance of not rain on Sunday. And so there should be some percent chance of rain or of not rain on for both days, for the conjunction of both days. But if we are adding that twice, then we're going to end up with that 100% chance. And so if we are not doing the subtraction, then we will get the wrong answer. We'll get something that is wrong. All right, so let's look at an example. So if the Browns have 2 children, the probability that at least one is a girl, which means that either the first is a girl or the second is a girl. And remember, this is the inclusive or, so we are also counting where both of them are girls. And so we have the probability of first is a girl or the probability of second is a girl, which is the probability that the first is a girl plus the probability that the second is a girl minus the probability that the first is a girl and the second is a girl. And so what we have is our 1/2 for the first one, the 1/2 for the second one, and then minus 1/4, which is the conjunction of both. And so if we then get the lowest common denominator, that's 2/4 plus 2/4 minus 1/4, which is 3/4, or 0.5 plus 0.5, which is 100, minus 0.25, which is 0.75. So there is a 0.75 chance that at least one will be a girl. So if we look at the classical definition here, we see, there is the chance where both of them are girls, and there is the chance where just the second child is the girl, just the chance that the first child is the girl. And so that is 3 out of these 4 possibilities. And so only when both of them are a boy do we not have at least one girl. So the frequentist definition then, so if you polled, say, 1,000 two-children families, that, approximately 750 of them will have at least one of their children being a girl. And so then we can look at this idea of the complement, which will end up making our calculations easier for these disjunctions, which is why I included it in this video. So the complement of a probability is just 1 minus the probability. And so 1 being, 100% chance. And so if we take 100% minus our probability, that gives us the complement. So if we look at this figure down here, if we're saying that in this blue circle here is, our probability of something happening, and we say that everything in this box, including the blue circle, is, equal to the 1 or 100% chance, then, if we want to subtract out this p here, then we would just do 1 minus p, and that will give us sort of, everything here inside the box, excluding the blue circle there. And so that is sort of the pictorial look at what a complement is. So if we say there is a 0.75 probability of having at least one girl, then there is a 1 minus 0.75 equals 0.25 chance of having 2 boys, which is exactly what we saw up here. There is the 0.25, the 1/4 chance of having 2 boys. But if we do the complement, we can make this calculation easier. So because instead of doing the calculation for, P first is a girl or P second is a girl, we can just find P boy and boy and then do 1 minus P, which is our, 1 minus 0.25 equals the 0.75. So the conjunction calculation is, simpler. It's just multiplying the same thing a bunch of times instead of doing all that adding and subtracting. And so if we want to think about, place where we have, a much more difficult calculation, because, this up here really wasn't that difficult. So an instance where that might be more difficult is if we consider a hypothetical family that has 20 children. So what is the chance that at least one of them is a girl? And so you don't want to have to go through all the different calculations, where first is a girl, or second is a girl, or third is a girl, all the way up to or 20th is a girl, which, is the probability of first is a girl plus the probability of second is a girl. And so there's all this calculation where if we just calculate the chance of all boys, it's just, boy and boy and boy, 20 times. So it's the probability of all boys, which equals 1/2 to the 20th power, which is, 1 in, just a little over a million chance that you'll have all boys. And so then we can do 1 minus the probability of all boys. So that's 1 minus this. And so I just made the 1 into the lowest common denominator here. So we're just subtracting this then. So we end up with, 1,048,575 minus 1,048,576, or, that divided by that, which gives us 0.99999990463. And so, in other words, it's an exceedingly high chance that at least at least 1 out of 20 of the children would be a girl. So the chances that, you know, all 20 children are a boy would be exceedingly small. And you could think about it too in terms of like flipping a coin. If you flip a coin 20 times, the chances that all 20 of them are heads would be very, very small. Not zero, but very, very small. And so this is how doing this complement here can actually simplify our calculations when we are doing this disjunction. But anyway, that is everything I had for this. In the next video, I will start on our discussion of conditionals, which is, kind of the thing that this has been sort of leading up to. So conditionals is that thing where, rationality really comes into play, and the fact that humans are quite bad at doing conditionals. Like I said, I tutor statistics, and probability is something that I find unintuitive myself. I'm better at doing things like linear algebra and multivariable calculus sometimes than I am at really thinking about probabilities. And so that's why I kind of hammer this point home here about wanting to subtract the one conjunction and things like that. But anyway, I don't want to ramble too much. I will see you in the next video.